Let's talk about errors. We all know that errors can possibly happen on the part of the programmer. I know it's hard to believe, but we do make mistakes. So let's see what some of these you've already encountered, I'm sure. Let's look at this little simple program that I wrote where we've got a numerator, a denominator, and then we're going to print out the result of dividing those two together. Now, first of all, if, for example, I had a syntax error, maybe I didn't declare my variable, or maybe I didn't put a semicolon, for example. I'm sure you've seen these errors before. When you try and run it, you get a compile error. And so right off the bat, we get this little error message, and in our error list, it gives us some kind of indication. We get, to the best of the compiler's knowledge, sometimes these messages are hard to understand, but it gives us a line number, and it says line number 11, we're missing a semicolon, and then we have line 14 or 15, we have this this variable that wasn't declared. So this is a compile error. We can fix, we've seen those before, I'm pretty darn sure. So we fix our compile error, and then now we can run it, and everything is good. We've gotten rid of the little red squiggly lines, and I'm just going to build it. I'm going to do a Shift Control B, which is does the build. It doesn't actually run it. So that's a good way to test your code as well. So everything looks good, and I no longer have a compile error. The second type of error that you might encounter is a logic error, which means let's say I meant to divide, but I accidentally put a plus sign. I wasn't really paying attention, and I ran my code, and it compiled just fine. But when I look at my solution, oops, what did I forget? I forgot to put a read key, so let's do that, so that way we can read key, see the result. Okay, there we go. So now when I run this, I got 15. Well, I didn't expect 15. I expected something else. So this is a logic error. And a logic error is just that. Everything works just fine, but it doesn't produce the output that I expected. So I need to fix my logic error. Oops, everything is in line there. Okay. But the last error, and one that we really need to address in this chapter, is a runtime error. For example, let's say I had a 0 instead. I fixed my logic error. I meant to do a divide, but for some reason I have a 0 in the denominator instead. So if I run this, everything crashed. Okay, so I get this error message that says we can't do this. We've got an exception. We've got a divide by 0 exception was unhandled, because it compiled just fine. Syntactically, it's correct. But once the program is running, it crashes because it encounters something that it didn't know would happen. And it gives us this crash, and everything just shuts down. Well, that's obviously not something we want our user to encounter. So we need to catch, as we call it, any errors that might be thrown during the program execution. We'd prefer that they get a nice message rather than this cryptic whatever. We don't want our users to be able to see this. Okay, so I'm going to close this down, and we're going to stop, and we're going to also look at another issue, and that is if I had done debug without debugging, just showing you, oh, I guess you can't quite see that. Let me see if I can pull that into. So if I had done debug start without debugging, then I would have gotten this error message instead, and everything crashes horribly, and we have either closed program. I can also debug it and go into Visual Studio from there, but we're just going to cancel all that. So I'm just basically showing you there the difference between start with, you can't see it, it gives out the screen there, start debugging or start without debugging. All right, so just a little side trip there. All right, so what we need to do is somehow take care of this runtime error. So what I'm going to do is just copy and paste here so I don't have to rewrite everything during this video. So I've taken the same equation and I've put it into what's called a try-catch block. So I have a try here and a catch here. And so what we're doing is catching whatever errors we might expect to happen during runtime. So this exception is kind of catches all. Any exception that might be thrown, we're going to catch here in this clause. And how this works is we use this first section that says try. And try says, go ahead and give this a whirl. Give this expression a whirl. And if everything else works fine, then we want it to print it. So I guess I should add that right line back in. Right line, print the result. So if this works, if it doesn't have an exception, then go ahead and print this line. But if it doesn't work, we want to catch that error before it crashes our system. An exception then is just a very general, any exception, anything that you might encounter, and we'll look at that a little bit more detailed in the next video. But overall, any errors that you get, instead of crashing the program, do this instead. So let's just run this and see what happens. We're going to step through it and see what happens. So I'm just going to put a stop on this so we can view it line by line. Okay, so we're waiting. Our console is running. It's waiting for us to react. We have our debug set, so I can step through each line of code and see what happens. So I'm going to step into this. This should have a problem because we're dividing by 0. So where will it go? It says, oh, there's an error. So notice it skipped the right line and it ran into our catch portion of our try-catch block. We have an exception. So we're going to run again. Okay, we have an exception. It's going to continue to run. And we'll print right line to the screen instead of seeing a big, oh, I missed that. Okay, so I missed the, I continued to run it without showing you the console. So we'll run it again just so you can see it then from the console's perspective. So the console then ran it. The console said, an exception has occurred, rather than giving us that big nasty error, and we could then continue with the program. So if it was correct, let's just do our correct, then of course everything runs fine, and we will see our division instead. So that's a try-catch block. That's the basics of a try-catch block. It will test something for us. It will try to run code for us that we think is going to run just fine. And then we're going to put in the second clause, which will only run if an error is thrown. If the compiler encounters an error, then the catch block will run. And in our next video, we'll look at this a little bit more detailed.